Imagine a planet so distant that sunlight takes more than 4 hours to reach it. A world where winds can move at incredible speeds, where seasons stretch across decades, and where temperatures plunge to levels almost impossible to imagine. For most of human history, Neptune was completely unknown. People could see the stars, track several planets with their eyes, and build entire civilizations around the movements of the heavens. But Neptune remained hidden in the darkness. Then, in 1989, a spacecraft that had left Earth more than a decade earlier finally reached this distant world. For the first time, humanity saw Neptune up close. What Voyager 2 discovered was nothing like the quiet, frozen planet many people imagined. Neptune turned out to be a turbulent world covered in powerful storms, surrounded by faint rains, accompanied by strange moons, and driven by an atmosphere capable of producing some of the fastest winds known anywhere in the solar system. And even after that historic encounter, Neptune continued to surprise scientists. To understand why, we have to begin with just how far away this planet really is. Neptune orbits the Sun at an average distance of roughly 4.5 billion kilometers. That number is difficult to visualize, so consider this. If you somehow had a road stretching all the way from Earth to Neptune and could drive continuously at highway speeds, the journey would take thousands of years. And there would be no rest stops, no fuel stations, and no shortcuts. Even light needs more than 4 hours to cross the average distance between the Sun and Neptune. That means when we look at Neptune through a telescope, we are not seeing the planet exactly as it exists at that moment. We are seeing light that began its journey years earlier. Neptune is classified as an ice giant, a category it shares with Uranus. The word ice can be misleading. Neptune is not simply a giant frozen ball covered in ordinary ice. Deep inside the planet, water, methane, and ammonia are believed to exist under pressures and temperatures so extreme that they behave very differently from anything we experience naturally on Earth. Beneath the atmosphere, these materials may form exotic high-pressure fluids surrounding a dense central region. The planet itself is enormous. Neptune is about 4 times wider than Earth and has roughly 17 times Earth's mass. Yet despite its size, Neptune rotates remarkably quickly. One rotation takes only around 16 hours. Its journey around the Sun is another story entirely. Neptune needs about 165 Earth years to complete one orbit. That means a person could live an entire human lifetime without seeing Neptune complete even half of one revolution around the Sun. Its seasons are extraordinarily long as well. Because of Neptune's axial tilt, seasonal changes occur just as they do on Earth, but on a completely different timescale. A Neptunian season can last for decades. Imagine entering winter as a child and still experiencing that same broad season when you are approaching middle age. That is how slowly Neptune's seasonal cycle unfolds. Humanity's discovery of Neptune was unusual because mathematics played an enormous role in finding it. Astronomers studying Uranus noticed that its orbit did not perfectly match their predictions. Something seemed to be disturbing its path. Instead of simply assuming their calculations were wrong, scientists considered another possibility. Perhaps an unseen planet was pulling on Uranus with its gravity. Mathematicians calculated where such a planet might be located. In 1846, astronomers pointed their telescopes toward the predicted region of the sky and found Neptune. It was one of the most impressive demonstrations of mathematical prediction in astronomy. The planet had effectively been discovered on paper before its physical location was confirmed through observation. Its name came from Neptune, the Roman god associated with the sea. The choice made sense. Through telescopes, the distant planet appeared blue, giving it an appearance that reminded early observers of Earth's oceans. But that beautiful blue color has a scientific explanation. Methane in Neptune's upper atmosphere absorbs much of the red portion of incoming sunlight while allowing more blue light to be reflected back towards space. The result is the deep blue appearance that has become one of Neptune's most recognizable features. Yet the color is only the beginning. Neptune's atmosphere is one of the most violent environments in the solar system. Winds can reach roughly 2,000 kilometers per hour or more, depending on how they are measured. That is several times faster than the strongest hurricane winds ever recorded on Earth. And there is an enormous mystery behind those winds. Neptune receives only a tiny fraction of the sunlight that reaches Earth. At that distance from the Sun, there is far less solar energy available to drive atmospheric activity. Yet Neptune's weather is remarkably energetic. The likely explanation is that the planet possesses a significant internal heat source. Neptune radiates more energy into space than it receives from the Sun, suggesting that heat stored or generated deep within the planet is helping power its atmosphere. That internal energy may contribute to the enormous winds and rapidly changing cloud systems seen high above the planet. And then there are Neptune's storms. When Voyager 2 approached the planet in 1989, its cameras captured one of the most famous features ever observed on Neptune. It was an enormous dark storm system known as the Great Dark Spot. The storm was comparable in scale to Earth. For a brief moment, humanity was looking at a weather system larger than our entire planet moving through the atmosphere of a world billions of kilometers away. But when the Hubble Space Telescope observed Neptune several years later, something remarkable had happened. The Great Dark Spot was gone. It had disappeared. Unlike Jupiter's Great Red Spot, which has persisted for centuries, Neptune's major dark storms appear to form and vanish over much shorter timescales. New dark spots have been observed since then, suggesting that these enormous atmospheric structures are temporary parts of Neptune's constantly changing weather. The temperature differences inside Neptune are equally astonishing. Near the cloud tops, temperatures can fall to around -200 degrees Celsius. But as you travel deeper into the planet, the environment changes dramatically. Pressure rises to unimaginable levels, and temperatures increase enormously. Scientists estimate that temperatures near Neptune's central region could reach several thousand degrees Celsius. That means this distant blue world contains an extraordinary contrast, a frigid outer atmosphere surrounding a vastly hotter interior. But until the late 20th century, almost everything we knew about Neptune came from a distance. We had never seen its atmosphere in close detail. We had never photographed its moons up close. We had never observed its rings from nearby. That changed with Voyager 2. Launched on August 20, 1977, Voyager 2 was designed to take advantage of a rare arrangement of the outer planets. The spacecraft could use gravity assists to move from one giant planet to the next, dramatically extending its journey without requiring enormous amounts of additional fuel. Voyager 2 visited Jupiter, then Saturn, then Uranus. And finally, after 12 years of travel, it reached Neptune. In August 1989, Voyager 2 became the first and so far only spacecraft to make a close flyby of Neptune. Suddenly, a distant blue dot became a real world. The photographs were extraordinary. Cloud bands appeared across the atmosphere. Bright white clouds moved through the upper layers. Huge storms occupied the planet's atmosphere. And the planet's blue color was far more striking than earlier observations had suggested. One particularly interesting type of bright cloud was made from methane ice particles high in the atmosphere. These clouds could move much faster than some of the larger atmospheric structures below them, giving scientists another clue about the complicated circulation of Neptune's atmosphere. But Voyager 2 was not finished. It also revealed something that had been suspected but never fully confirmed. Neptune had rains.